You have to be able to graph a logarithm correctly, you guys, and it's not hard. So as long as you know what you're doing. We did one example last time like it. So I'm not asking you to graph this one. There's a lot of interesting things in this shifted logarithm that we're going to talk about, but I am just asking you vertical asymptotes, x-intercepts, and domain. But we will talk about how you would graph it if you were asked to. Okay, first of all, guys, everybody listen to the steps you take to graph or look at a logarithm. I'm going to want at least a rough sketch of this logarithm. That's why I drew XY charts to determine vertical asymptotes, x-intercepts, and domain. So from here, what you do, everybody, is you go and say, what would the parent function be for that logarithm? Which would be y equals log to the base 3 of x. Take off the shifts. Does everybody hear step number 1? Step number 2, get some xy points for log to the base 3 of x. Well, you can't get points without a calculator. So you're not going to do it this way. You're going to say, well, I'll push pause on that. I'm going to do base 3 to the x and find some xy points for that, since that's the inverse. So plugging in -2, -1, 0, 1, and 2. So we would get 1/9, 1/3, 1, 3, 9. I don't want those points. Those are the exponentials points. They're just going to help me now get the logarithm's parent function points. Correct. So your next step is to switch them. 1/9, -2, 1/3, -1, 0, 1, 0, my bad, 1, 0, 3, 1, and then 9, 2. Now that would just be the parent function's xy points. Does everybody see? Now from here we can perform the transformation to those xy points and boom, there's your graph. But once again, I am going to just show you, let's look at the parent function and what it looks like. So don't we know that all logarithms with no shift left and right have a vertical asymptote at x equals 0? That's always going to be true for a non-shifted logarithm. So the parent function, log to the base 3 of x, will look as such. So then look, I'm going over 1/9 down 2 units, over 1/3 down 1 unit, over 1 up 0, over 3 up 1, over 9 up 2. Here is the parent function of the log base 3. So for this one, wouldn't a non-shifted logarithm always have a domain of 0 to infinity? And a range of -infinity to infinity. Now notice my vertical asymptote on this one, on the parent function, is x equals 0. My x-intercept is always when y equals 0, so we know it would be 0, 1. And then our domain we already just talked about, 0 to infinity. Okay, now let's take these xy points and transform them. Now here's the catch. We have actually not really seen this caliber of shifting, meaning, do you see how we have a -2 in front of x?
Yeah.
We've got to actually factor that out. Now I don't mean out, it is inside the logarithm, but I mean factor it out so that there's just a 1 in front of x. So if we pull out a -2, we'll divide by -2, divide by -2. So then left in my parentheses will be x minus 2. Do you agree? Okay. Now in words we can verbally describe the transformation. So I just want to remind you, if you have a negative inside your parentheses, inside, that's a reflection over the y-axis. That will affect your x values. So we're going to go to our x values and we're going to times them by -1. Then from here, we have to look and see this 2 right here is different than having a 2 in front. A 2 in front is a vertical stretch of 2. Do you all agree? That is true. Now, that would affect your y values. We have not learned, really, we actually have not learned when we have a 2 inside what it's going to do. It's going to be opposite of what you think. So this is actually do you see how we're timesing it to x instead of our y? If it's out in front, you're timesing it to your y values. Now, do you see how here it's taking and timesing it to your x's? What you're actually doing is you're doing a horizontal shrink of a half if you reciprocate it. We're not going to really get into that today. You're not going to be tested on that. So, but honestly, if I'm just asking you vertical asymptote, x-intercept, and domain, isn't a stretch or compression not going to really matter for domain? Like it's just going to go quicker, higher, or lower. Does that make sense? Quicker, slower? So I'm just going to say, okay, I'll just write it down. It's a horizontal. It's a shrink of a half. It goes opposite if it's inside, interestingly enough. We won't get into why of today. So that would affect your x values. So we would times our x values by 1/2 as well. But really that's not going to matter for our rough sketch. And then we're going right 2 units. Do you agree? So that's the first thing I'm going to do. Right 2 units. Our asymptote used to be at 0. It's now at +2. So when I say what's the vertical asymptote, you'd say at x equals 2. So adding 2 after we times by -1. I'm really, like I said, I'm not really worried about, we have to actually, if I ask the x-intercept, we're timesing our x values by also 1/2. So times by -1/2, we'll just do that, hit 2 birds with 1 stone. If I was going to write down my new xy points. But just a reminder, it's also reflected over the y-axis, so won't it be this way now? Okay. Now we just need to know when it's crossing right there, don't we? We could just do some math and calculate it. So we could do that. We could also just do the math right here. Isn't our x-intercept always when y equals 0? So now we just got to find our new x value. So you do 1 times -1/2, which is -1/2, and then added to 2. So 1.5. So you'd say 1.50. I'm telling you, on this test, you won't be tested on this. You'll have the 2 in front. So then you just times your y values by 2. So don't worry too much about that weirdness. The main thing I wanted you to remember is that you have to factor out, if you have something in front, you do have to factor it out before you do the shift left and right. Now our domain, isn't it going to be -infinity up to 2? Yeah. Look at the rough sketch of the graph. Yep, so -infinity up to 2. Does it get a bracket or parentheses? Parentheses, because it's a vertical asymptote, which we will never ever cross a vertical asymptote. All good with that? Yeah. For the most part? Okay. So what are the steps to graphing the logarithm? Write down the parent function. Find the exponentials xy points, switch your x and y, then perform the transformation to your logarithm points. Does that make sense, the steps? Okay. When you get to the test, I need to see those steps. Okay, moving on. So let's just review a couple of things from last time's lesson. Remember, you should be able to simplify these things in 10 seconds. Less, honestly. Base 3, log the base 3 to 10. You shouldn't be writing it down because it should take you less time to just tell the answer. 10. Doesn't base 3 raise to the log base 3 undo each other? Inverses undo each other. And ln of e squared would come out to be? 2. Good. ln and e undo each other. You're awesome. Alright, continuing to remind ourselves what we learned last time. If I said take this exponential statement and write it in a logarithm statement, you would do log base 5 of both sides, wouldn't you? So now log base 5 and base 5 cancel out, so we have 3 is equal to log to the base 5 of 125. It's now in its logarithmic form. Alright, now write this ln in its exponential form. E both sides, e and ln undo each other. So my true statement is now 4 is equal to, E, we'll make that into an E raised to the 1.386. Do you agree? Okay, how would we write this one as exponential? Base 16 to the... I'm just asking for the answer. Oh. So base 16 raised to the what? 8. No. 3/4 would equal 8. I'm just asking for the answer, guys. Sorry. Oh. Okay, right here. What's just the answer? ln of 7 equals 2. Okay, good. Awesome. All right. Let's go on to today's lesson. Okay, yeah, this is the start of today's lesson. Just a reminder, everybody, recall that if you have log to the blank base of x, that's really a base 10 secretly. I want you to look at your calculator. So some of your calculators have some advanced functions. Now, so when I always have students, when I say, look, your calculator only has log blank base. Doesn't that say log base 10 we know secretly? Yes. So your calculator only has log base 10 and ln's. And then people go, no, mine has one. Well, you can't use that function, so pretend it doesn't. There are some people's calculators that have a place that you can put in the base. Oops. But don't do it. Okay. You can only use this log button and this ln button. Do you all hear that? Okay, but there's going to be a way we can calculate with all log base 10s. So everybody look, if I said to you, you can rewrite log to any base of x as a base 10, so you can type it into your calculator, Here is the formula you use to do that. So write this down. This is called the change of base formula. So everybody listen, the change of base formula allows us to take a log of any base and rewrite it so it has base 10 so that they have both this, so it has all base 10s. So then we can type it into our calculator. So right here, log to the base a of x is technically, this x is in parentheses, can literally just be rewritten. It is equivalent to log of x divided by log of a. So you can take something of this caliber. So for example, if I have log to the base 2 of 5, I can literally rewrite it as log of 5 divided by log of 2. Now look why that might be useful. You can't type that into your calculator, but you can type this in, can't you? You take log of 5 divided by log of 2. Does that make sense, everybody? So look, it changes them so that they both have the same base 10. And then also, you can also just do ln's. So if you have log the base a of x, you could literally do ln of x divided by ln of a. Now notice, whatever is in parentheses is always the one that goes on top. You've got to remember that. The base part goes on bottom. Log of the base always goes on bottom. So you notice, log of the base 2 is on bottom. Log of what's in parentheses is on top. You could also write it as ln's. So we could have done log of 5, or we could have done ln of 5. Divided by log of 2, divided by ln of 2. It'll calculate to be the same. This and this will calculate to be the same. So now that's useful, because now if I give you something that you can't solve by rewriting it as an exponential, you can use the change of base formula. So look, last time I said to you, evaluate, and I gave you a logarithm, just a reminder, okay? Log the base 425. Now last time we did this, we said we don't know what it is, so we set it equal to a question mark. Do you remember doing this? And then we base forward both sides and rewrote it in its exponential form, right? And then we were able to solve by writing them both as the same base. Can 25 be written as base 4? No, so do you guys see how we're stuck? We can't solve this one by this method. So it's because we're not going to have a quote-unquote pretty answer. It's not going to be a whole number or a fraction that we know. So instead we're going to have to use the change of base formula. So we would rewrite this as log of 25 divided by log of 4. Using the change of base formula, we're now able to calculate it or evaluate it without rewriting it as an exponential. So give me the decimal and type it into your calculator, everyone. So your instructions will tell you what decimal place. Let's go 3 decimal places. So that'd be 2.322, roughly. You guys see? Now watch, try typing in ln of 25 over ln of 4, and you'll see if you hit enter, you get the same decimal. So as you can see, it really doesn't matter. You can use ln's or logs. Isn't that kind of nice to have? So let's pretend you couldn't figure out, like what if I said log to the base 2 of 4, and I said solve by rewriting this in its exponential form. So that would be 2 to the what power equals 4. But that one's easy, right? 2 squared. But let's pretend you didn't know. Then you just do the change of base formula, even if it was an easy one. Okay, try again. Just make sure you're good with this. If I said to you, evaluate log to the base 2 of 12. Once again, I'm showing you if I tried to write it in its exponential form, they can't be written as the same base. So we would not solve this one by this way, but instead the change of base formula. So they're both going to be base 10. Log of 12 over log of 2. Isn't that how we rewrite it? So then you get decimal what? Good. 3.584, you said roughly, right? Okay, cool. Moving on. Okay, we'll come back to this. I want to talk about later, why does the change of base formula work? It's actually really straightforward. It's just algebra. It all works out, and we can come back to that. Don't let me forget if you want to know why the change of base formula works. But let's get going into this part because I think it'll make more sense of why the change of base formula works once we've learned the lesson. Okay, so properties of exponents, you don't need to write down. But here's the thing. We know exponentials and logarithms are inverses of each other. So if you know properties of exponentials, you know properties of logarithms. So I'm just going to give you some examples. These are things we already know. Base 2 to the x times by base 2 to the y. Well, this is a properties of exponent problem. When you multiply the same base, you can write it as, when you multiply the same base, you can write it as one base. When you multiply, you add your exponents. And now we've written it as 1 base 2. Does everybody see? There's one property of exponents. we have base 2 to the x divided by base 2 to the y. We can write it as 1 base 2, and when you multiply, you add. When you divide, you subtract, and you always subtract the top from bottom. Do you see how I've written it as 1 base 2? And then our last property of exponents is raise the power to a power, and you multiply. So this would be x times y. Okay, good. If you know those three properties, you already know your properties of logarithms. Since they're inverses, they go hand in hand. So start writing these down right here. The product, quotient, and power property, these are the only three properties you have to know. They're actually really straightforward. Like we flew through this first hour. Write them down and then we'll talk about them. So as you're writing them down, notice it says you have the product property. So look, when you multiply, you add. Everyone look up here while you're writing real quick. When you multiply, you add. Do you see how it's the same product? It's the same property. So if you have log to the base a of u times v, you can split it apart with an addition sign. So you can rewrite this as two separated logarithms, obviously both base a. So log base a of log base a of u, then when you multiply you add, plus log base a of v. Now that also works for ln's. They're just logarithms, so we can also do that. Now honestly, more importantly, just like on that last example, when I had two separated exponentials, I wanted to put them into one base. Really how we use this property is we work backwards. If we have two separated logarithms and they're both the same base, we can put the log together as one base, so they're both the same, and then we can put it together. And then so when you add, you multiply. So you got to think backwards. When you multiply, you add. When you add, you multiply. It's usually better to have one logarithm than two separated logarithms. They have to be the same base though, just like properties of exponents. Okay, quotient property. Notice when you divide, then you subtract. So same rule. So if you have log to the base a of u divided by v, notice the log to the base a of u is positive because it's on top. The divide sign creates the minus, and then log to the base a of v. So really going the backwards way is more important. So if I was to take this and say I can write this as 1 log base a, and then it's u's positive, so it goes, in front is positive, so it goes on top, subtract is divide, and then v. Same with ln's. This power property is a little teeny bit of a stretch. It is a power to a power type idea, but I'm going to give you just a second to have it written down so when I show you this next part, you can be watching. So I'll push pause. Okay, look at this piece right here. So if we have log to the base a, it's technically a base u raised to the n. So it's kind of like a base and a base. Do you guys see? This n is an exponent. We can take the exponent and we can bring it down in front, being multiplied. So it's kind of like raise a power to a power and you multiply it, but you multiply it in front. So if you have something multiplied in front, like so this n is multiplied in front, really what's more importantly is to be able to go backwards, to remember, oh, that's just an exponent, and just bring it back up. So that the logarithm's all by itself. Kind of make sense? Yeah, let's put it all together. Notice there are only three properties we can use. When you multiply, divide, and then a power rule. Okay, so let's now answer. It says expand the logarithm. That means break this apart. So just a reminder, times signs are addition signs, correct? Divide signs are subtraction signs. So right here, do not think that 5 and x cubed are connected. These are times signs. Times signs get split apart by addition signs. So these are all log base 4s. Technically that's in parentheses. It's just this book's kind of lazy and doesn't write it. So we can write this as separated logarithms. This is log to the base 4 of 5. Because it's a times sign, it's a plus sign. Plus log to the base 4 of x cubed, right? Times sign, so plus sign. Log to the base 4 of y. Then our last step, if we're expanding it, is to take anything that's an exponent and have it times in front. So we would take this 3 and pull it in front here being multiplied. And then I'm going to just scribble that out. That's the expanded logarithm. And done. Yay. Yay. Pretty easy, right? Let's do another one. Expand the logarithm. So this is technically all in parentheses like this. So anytime I have radicals, you guys, it's really just exponents. So I'm going to rewrite it. This is ln, the same problem. I'm going to rewrite it. It's 3x minus 5 to the 1/2 power divide by 7. Now remember, there are three rules. Multiply, divide, and powers. That's it. Okay? So just keep that in mind. So can we split apart a subtraction? No, it was when you divide, you subtract. You cannot split apart a subtraction inside. Does everybody see? So this is ln of 3x minus 5 to the 1/2 power. Then this divide sign creates a minus sign. ln of 7, and then don't we just need to bring 1/2 down in front? And then we're done. That's expanded. Don't be tempted to split apart this subtraction sign. It didn't work that way. It's either when you multiply, you can split apart with addition. When you divide, you can subtract. And you have powers. See, that's it. Okay. All right, let's keep going. So here is one that has a piece that kind of confuses people. So everybody look. Let's try to hit 2 birds with 1 stone, however. Let's do the exponents and the addition signs at the same time. Do you see what I'm saying? So, do you see how there's a times sign and a division sign, and then we have powers, don't we? Division signs, and then we have our powers. Isn't this z to the 1/2? So just a reminder, that's the 1/2. Okay. So let's do this in 2 birds with 1 stone. Won't there be a 2 in front? Log to the base 3 of x. Does everybody see where I'm getting that? When you multiply, you add. So we have plus. Now we have a 3 in front from this exponent. 3 log to the base 3 of y. Now isn't it a divide sign? Subtraction. And then we have a 1/2 in front. Log to the base 3 of z. Now guess what people want to do? They say, so now it's times again, so add. That's incorrect. It's on bottom, isn't it? Bottoms need subtraction signs. So we actually have minus again. Minuses bring it to the bottom. Additions have it on top. So minus log to the base 3 of p. Now here's once again y. So I had somebody ask last hour, can I do minus and then in parentheses have the 1/2 log to the base 3 of z plus log to the base 3 of p? And I said, absolutely. Isn't that exactly what's being created here? A times sign on bottom. The negative flips them both. Do you guys see? I just distribute my negative. I say anything on bottom gets a negative. Anything that's positive is on top. Does that make sense? Okay, great. Try it by yourself. Expand the logarithm. Go for it. Just start for the video because I think you guys are getting it. Hey, here's how I personally thought through it. I know some of you probably thought through it different, which is great. I first said, so really what I have here is an x cubed y to the 1/2 power. And then it's not breaking the forbidden rule because that's a times sign to 1/2 that, 1/2 that. And then on bottom I still have the same as above. I just am rewriting the top. So the top is actually an x to the 3/2 and a y to the 1/2. That's how I personally did it. And then the bottom is the same as over there. So now from there, I went for it. I split it apart. I said I have a 3/2 log of x plus sign 1/2 log of y. Now divide means subtract. Minus 2 log of z. Subtract sign because p is also on bottom. 3 log of p. And then it's subtract again log of q. Do we have any questions I would love to answer? So please ask. Yes. Yeah, because when we multiply fractions, we'll multiply straight across. Great question. Yep, so yours is just more in like a non-standard form, you know what I mean? But it's the same answer if you have your parentheses and your 1/2 in front. Great, I would accept that as well. Okay, great, awesome. Okay, let's keep going. Let's go the other way now. Here's really the important thing. The reason we expand is so that we can condense. Now, it's because it's better to have 1 log than 2 separated logs. So everybody look. We are putting this into 1 logarithm. Do you guys see how we can? They're the same base, aren't they? So this is how I start out. I say, well, I can write this as 1 single logarithm. And then I put in parentheses, and I just place things where they need to be. So it's a plus sign, so doesn't that mean multiply? So this is an exponent, and this 3 is an exponent. So we have an x to the 1/2. Then we have a times sign, x plus 1 to the 3rd, don't we? And then how we would write it as any fractional exponents would be rewritten as radicals. So this is really root x times x plus 1 cubed. And that would be your final answer. Only write one log. I always have people on the test write multiple logs. Well, that defeats the purpose. We put this into one logarithm to only have one logarithm. Like they'll write log divided by log and stuff. I don't know. It's weird. Okay, let's do this one. You try it by yourself. Put this into one ln. So I literally, when I'm condensing, I go, so I have ln, I put parentheses, and I just place stuff in the correct spot. Answer. Good. The subtraction creates the division. Awesome. Easy. Let's do another one. Condense the logarithm, go for it. So anytime I'm asked to condense, I just start out with going, okay, I have 1 log base 2, I put in some parentheses, and I start putting stuff in. Is cube root of x times x plus 1. Agreed. Now, I just want to remind you, a lot of people will see this and say, so all this stuff is under the cube root. But here's the thing, guys. We distribute a 3rd through, don't we? You guys see? Then that's an exponent. That's an exponent. So the log part doesn't have the cube root. Okay. Try again. Condense the logarithm. We'll just keep getting harder and harder. So once again, like the easiest place to start is go, okay, so 1 log base 2, put in some major parentheses, and then just start putting stuff in. Step problem. What goes on top? X, good. Divide. Y, Z to the 5th. Does everybody see? When there's a subtraction, it just flips it. All good? Pretty straightforward stuff, huh? Okay, let's try again. Okay, so here's the thing, guys. People will get thrown off because of the addition and subtraction being all over the place. But is 2 plus 3 any different than 3 plus 2? No, so we could reorder this in any order. We could put all the positives first and then all the negatives last. So this is still just a subtraction sign. Subtraction sign. Addition, addition. So you'd say I have 1 log base 3, big parentheses. I know there's a subtraction sign, so there's a division sign. Anything that's positive goes on top, so that'd be a y and a square root of p. Do you agree? Yeah. Then on my bottom is an x to the 3rd, right? Because that's the subtract means divide. And then also a z. Okay, good. You guys did awesome with that. Okay, so you guys think you could do this one? Yes, you could. Try it. Just write down the answer. I guess we could just verbally state it right now. Would you rather do that so you can just go quicker? Or would you rather let me give you a second? Okay, awesome. The end here. So you're right. So you said, okay, x goes on top since it's positive. We also have a 5th root of p on top, right? Since it's plus. Divide, and then it looks like you have a square root of y times by z. Awesome. Any questions on that? You guys did really, really good. Okay, cool. Okay, I'm just going to go over some things that are on the homework that are worded a little weird that people kind of have a hard time getting started with, and so that we can, when we get to the homework, not have such a hard time. Okay, it says, write each in terms of an ln of 2 or ln of 3. So I want you to take their ln and rewrite it with only ln's of 2's and 3's. So basically, you need to rewrite it so it's 2's and 3's. So isn't 6 ln of 3 times 2? That's the same thing, correct? Now how do we split that up? ln of 3 plus ln of 2, and done. Okay, let's look at this one. There's many correct answers, keep in mind. So isn't this ln of 2 and then divided by, I heard 3 times 3 times 3. I agree. Yeah? Or 3 cubed? Okay. So, or ln of 2 divided by 3 cubed, both all equally correct. So if I was going to do the bottom one, wouldn't I have ln of 2 minus sign 3 ln of 3? And then that's it, right? Okay, let's read this next one. It says, find the exact value without using a calculator. Don't overthink it. We've learned properties of logarithms. Don't overthink it. What would the answer be right here?
Well, it's 3.
Almost.
No. 1/3.
1/3. Does everybody see why? Yeah. Isn't that log to the base 5 of 5 to the 1/3 power? Doesn't log base 5 and base 5 cancel out? Okay, so then answer of this one. 4, right? ln and e cancel out, don't they? 6 minus 2 is 4. Okay, right here it says this is 18 on the homework. Yes, it's an even because I didn't want to take away your odds, but it is. The hard thing for people is they don't know when to stop. So everybody listen to my thought process. It says simplify using properties of logs. That means you need to simplify this down as far as it can go till it can't keep simplifying. So here's what I focus on, everybody look. I see that I have a log base 2. Now won't log base 2s and base 2s cancel out? Yeah. So what I try to do is rewrite everything as much as I can as a base 2 inside. So everybody look, I have log to the base 2. Now isn't 4 squared 16, but I'm trying to go for base 2. 2 to the 4th, and then we have times 3 to the 4th, and there's nothing we can do with the base 3, right? When you multiply so we have log to the base 2 of base 2 to the 4th plus log to the base 2 of 3 to the 4th. Now can't we bring our exponents in front? So we have a 4 in front. We have a 4 in front. Okay, now what does log to the base 2 and base 2 do? Yeah, they cancel out to become a 1. So 4 times 1 is 4. So we have 4 plus, and then there's nothing that can happen here, right? Nothing that cancels out. Base 3 is as far down as it gets. So then you have plus 4 log base 2 of 3. That's when you know to stop, when you can't keep going. Yeah. Next. Try another one, because they get a little bit more intense. There's many ways to do it. That's the hard thing. Okay, we have log of 9 over 300. It doesn't give you a specific way to simplify. But notice, isn't this base 10? Yeah. So I try to get any base 10s, as many as possible is going to make my life easiest. So I'm just going to rewrite this original problem. So isn't this log of, does 9 over 300 actually simplify? Yes. What is it? 3 over 100. I'm going to go with that. I'm going to simplify first. Now, I want base 10s, so isn't this log 3 over 10 squared? When you divide, you subtract, so isn't this log of 3 minus 2 log of 10? And then remember, this is secretly log base 10 of base 10. So there's your final answer, log of 3 minus 2. It's not bad, as long as you kind of get where to go with this. Okay, 22, simplify using properties of logs. So you'd say, okay, well, when you divide, you subtract. So this is ln of 6 minus ln of e squared, isn't it?
So it would be minus 2.
Yep, so ln of 6 minus 2. Okay, right here, log, this is 19. I think this one is on the homework, by the way. Log to the base 5 of 1 over 250. Now, once again, base 5s we like, because that's going to help us simplify easy. So we have log to the base 5 of 1 over, isn't 250, let's write some 5s. You said what? Isn't it like a 25 times what? 3, 4, 5. 3, wait. I'm overthinking this. 25 times 3 is 75 people, right?
25 times 10.
Yes, duh. 25 times 10. Yeah? I'm making this harder than it needs to be. So isn't this 5 times 5 times 5 times 2? Yeah. So I'm going to go like this. 5 cubed times 2. Because then won't that be the easiest probably way? There's many correct ways to do it. So now let's do this. Split it up. Log the base 5 of 1. The parenthesis. Minus log to the base 5 of base 5 to the third. Minus log to the base 5 of 2. Now from here, if you can remember from last time, log to any base of 1 always simplifies to be 0. So that's 0. So then doesn't this also cancel out? So we have negative 3 right there. And then there's nothing more we can do here. Minus log to the base 5 of 2.
And then when we distribute that negative.
You mean factor it out? Because it's distributed right now.
Right.
So you could leave it or you could factor it out. Because standard form and factor form are equally good. Awesome, that's the end of the lesson. The rest of the time's yours.